So now we're going to have another look at sampling. So this is the sampling second section. So now we're going to have a look at the other sampling methods that can come up in A-level statistics. As stated before, sampling is very important because otherwise the hypothesis test that we perform can be invalid, and also the three sampling methods that we have already covered is the simple random sample, the systematic sample and the unrestricted random sample, and to see those videos please have a look at the other sampling video. So now we're going to have a look at the other sampling methods that come up. To start off with, we're having a look at the proportional stratified sample. So this is where we split our group into separate sections, also known as strata, and we choose a random sample from each in the proportion to the size of the group. This is actually performing a simple random sample within the groups, and I'll explain that when we get onto the examples. So the formula for deciding how many people from each group we're going to choose is the number of people from the strata is the number of people within the strata, so within the group, divided by the total population times the sample size. So for example, if we had 18 boys and 12 girls and we wanted to take a sample of 10, we'd have 6 boys and 4 girls. So that's done by, in total, 18 boys and 12 girls. So we have a population of 30 in total. So for the boys, we would have 30, so the number within the strata is 18, because we've got 18 boys, divided by the total number of the population, which is 30, times 10, which gives us 6. And then similarly, for the girls, we would have 12 divided by 30, times 10, which gives us 4. So now we're going to have a look at the disproportional stratified sample. So for the proportional stratified sample, as the name suggests, we take samples in proportion to the size of the group. With a disproportional stratified sample, we still split the population into strata, but this time we just take equal sized random samples from each of the group. So if we had 5 boys and we had 5 girls and we wanted to take a sample of size 10, we would have 5 boys, 5 girls. So we're taking an equal number from each of the stratas. Now you can already see why a proportional stratified sample is preferred to a disproportional stratified sample, because here we are including all 5 of the girls in our sample, whereas of the 25 boys we're only asking 5 of them for their opinion or point of view or whatever it is that we wanted to collect data on. So this is giving an unrepresentative look at the girls, whereas when we had our proportional stratified sample, this is one of the best ways that we can get a representative view of the population that we're trying to look at. Obviously, that depends on what you decide your strata is going to be. Strata can be anything that is a defining characteristic of a person. So that means that it could be their hair colour, eye colour, it could be their gender, as it is here in these 2 examples, but it could be something like their religious beliefs or their ethnicity, anything like that that you think is going to make a difference when you are taking your sample. So usually it's a good idea to split your strata in a way that you feel is going to influence the results, and then you can get a proportional view if it's a proportional stratified sample, or a view from each group if it's a disproportional stratified sample from each of those groups. Now we also have a cluster sample. A cluster sample is where we divide the population into clusters. Now this is different because this is done geographically. So for instance, if we were wanting to take samples from here, We are saying postcode is a good way to do cluster sampling. So instead of taking a sample of, let's say, the entirety of Manchester, instead you would choose selected postcodes and then give your question out in those postcodes. But it could be something as simple as if you were trying to take samples from a river. If, say, we were having a look at a school trip where we had to collect data from along the river, obviously, in order to supervise the pupils whilst they were doing this, it would be very difficult to do that if we were to do, let's say, a random sample of the sections of the river. And instead, it would be much simpler to monitor the pupils doing their sampling if you were to perform a cluster sample. So having, say, sections 1, 2 and 3, and then 7, 8 and 9 would be much easier to have 1, 5, 9 and so on. Because that way, you can keep the pupils in a smaller area. So a cluster sample would be more beneficial in that sort of circumstance where you're wanting to limit the amount of travel that you're having to do or help with the amount of supervision that you're having to provide. Then we're looking at a judgmental sample. So a judgmental sample is where the researcher uses their own professional experience and expertise to select and identify participants from the population, and so that then they can be part of their area. Now, this is the sampling method that has a high experimental bias because the experimenter is choosing who is in their sample. So that means that the results are very swayed, but it also means that somebody with a very limited understanding of statistics can easily perform a judgmental sample. And also you are asking people that understand what you are wanting to talk about. For instance, if you wanted to do a survey on fashion, if you were to ask some members of the population, they might not have a very good grasp of fashion. Whereas if you were to perform a judgmental sample, you can make sure that you include people that understand the premise of what you're wanting to ask them about. The last sampling method that we're going to look at is called a snowball sample. Now, this is very good for if you're wanting to do research into groups which are unlikely to fill out a normal survey. So the researcher identifies one relevant participant with a specific characteristic and then uses them to find other participants with the same characteristic. This is particularly used for proportions that are difficult to sample. For instance, if we were to research into the habits of drug users, it's going to be very hard for a researcher to get a large group of drug users to participate in their survey. Whereas if they got one relevant participant to feed them back information, then that means that they are able to gather the information without having to actually interact or get the drug users to give them the information. So this is good as it means that you are more likely to get an honest result because they are more likely to tell a friend the truth than they are to tell somebody that they don't know, especially if it's an illegal habit like drug using. However, you are having to trust your one participant to actually go out and perform the survey. So as I've just been talking about when I was describing the different sampling methods that we're having a look at, there are a series of pros and cons to each of these. I'm just quickly going to go through those with this table here. So from the last time that we did the sampling video, a simple random sample, it is quick, easy, cheap, and it removes experimental bias. That's why we have to be careful and put the names into a list that is unbiased, like alphabetically or date of birth order. However, it does also come with some disadvantages, such as it may not be representative. It may be a problem to gather a full list of the population before we start. It requires a sampling frame, which means that we are having to get all our participants' names, we're having to put them into an order, we're then going to have to number them, and all of that does take time to do, especially if you've got a large population. that you are wanting to sample from. So that's what it means by the sampling frame. If you have a look back at the other video, it describes how we come up with the sampling frame. And some people that are selected may not want to take part, which is why last time we talked about contingencies that we could put in place, such as taking a larger sample. That is the best contingency that we could have. For an unrestricted random sample, remember that that is the same as a simple random sample, but in a simple random sample we ignore repeats. In an unrestricted random sample we include repeats. It's still quick, easy, cheap and removes experimental bias. However, it still might not be representative. The same person may give their answer more than once, because remember that we're including the repeats this time. Maybe a problem in gathering the whole list and making the sampling framework. Again, that's described in the other video. And some people selected may not want to take part. For our systematic sample, it's still quick, easy, cheap and removes experimental bias. However, it still might not be representative, even though you are more likely to get a representative sample than with a simple random sample, because depending on how you order your list to begin with, depends on how many, you're going to have an equal spread of those experiences. For instance, we had an example in that video on years of service, and you were trying to get an opinion from them. So if you put them in years of service order, you're going to have some people that have just started, some people that have worked there from a medium length of time, and some people that have worked there for a long length of time in your sample. However, you still have to make that sampling frame first, which is quite hard to do for some situations where you may not be able to get that data. Some people may still not want to take part, and also if the population is divided by the sample size, then it might not be fair or might not have an equal chance if the population does not divide by the sample size to give you a greater or less chance of being asked to participate. So when we were doing the example on the systematic sample, we had an example where it divided and it gave us 49.25. So that might not end up giving us a fair chance of being chosen in the survey. Because, for instance, there we talked about the fact that we had to round it up to 50, because otherwise the people at the end of the list would have no chance of being chosen. But that also means that you would have to cycle back round, which means the people at the beginning of the list have a greater chance of being chosen than people later on in the list that will only have one chance of being chosen. Proportional stratified sample. This is going to be representative depending on how we split our strata, our groups up. And it still removes experimental bias because within those groups we are performing a simple random sample. However, it is very time consuming, and we need to know the information about the population in order to break it up into the strata before we perform the sample. That can be quite difficult, especially if you're wanting to do something such as religious views as your strata. Sometimes it's very hard to find out everybody's religious views in the population before you perform your sampling method, because you need that to split them up into the strata. And also, some people may be more enthusiastic about their religion than other people, and that means that it's very hard then to, even within the groups, have separate strata. We also have a disproportional stratified sample, and same as with the proportional stratified sample, it still removes experimental bias, but this time it's not going to be representative because we don't have the same amount of views in proportion to the whole of that strata's size in our sample. So as we saw before, we had 5 girls in total in our population, and all 5 of those ended up being in our sample. So that means that it would no longer be representative because the girls are having an equal viewpoint made than the boys, but there are much more boys in the population than there were girls. And again, it's time consuming. We need to know the information before we can do our sample, and it will not be representative this time. Then we have our cluster sample. Remember, a cluster is very similar to a stratified sample, but this time we're talking about splitting it geographically. It's easy to implement because you can just easily get everyone's postcode or easily split destinations up into sections. It's quite quick to perform because you're just choosing that location. You can do it using a random number generator or something like that to decide which ones you're going to. It's quite cheap to perform, and it does remove experimental bias as long as the clusters that you are going to look at are chosen randomly. However, it won't be representative because some sections won't be looked at or some postcodes won't get their viewpoint across. And also it requires you to have a sampling frame before you start that. So it requires you to have all the postcodes, all the sections of the river in order for you to then do your sampling of them. A judgmental sample, it's quick and easy, and people included will be able to give detailed information about what you're asking them questions on because they should be semi-experts in the field of what they're looking at. But this has a very high experimental bias, and also it's definitely not going to be representative of the population. In fact, it is one of the most biased sampling methods. And the last one that we talked about was the snowball sample, which, as we said, is a good way to get honest information from people. It's a good way to access hard to reach groups. But again, it's not going to be representative. People may still lie, which is the main reason why we're doing a snowball sample, is to try and get around the fact that people might lie, especially about illicit activities. And also, it usually used when questioning on illegal activities, so they're an unreliable sampling pool as it is. So that's the pros and cons, as you may, of the different sampling methods that we've talked about. We're now going to have a look at an example of how we would perform each of these sampling methods. So our example is this. We have 1,200 pupils in year 11 in an 11 to 16 school. So that is year 7 to 11. The head teacher has heard that there has been an incident of bullying on the school bus. The distribution of pupils in the year groups is as follows. So we can see here that we've got the year groups and we have the genders of the pupils. And we're explaining to the headmaster how they would perform each of the sampling methods that we've had a look at. So, for the simple random sample, sorry, I've just made it a bit bigger so that then I can write in it a bit more. So for a simple random sample, we're first going to put the pupils in alphabetical order by surname. We're then going to number them from 0001 to 1200. Then going to use a random number generator to generate a random number between 0001 and 1200. We're going to repeat this ignoring repeats because it's a simple random sample. Until we have a sample of, I'm going to add a bit here saying that we're going to take a sample of 100 just to help me with this example. It doesn't state the sample size, so you could just say a sample of the required size, but just to help me later on with the stratified sampling one, I am going to have to know what the sample size is as well for the systematic one. So sample of size 100, and then we're going to ask the selected pupils about the bullying incidents. So you need to be careful and make sure that you read the question carefully. I have seen some pupils before say that they're going to give a questionnaire to barnyard animals. You have to make sure that what you are trying to do is what the question is asking. So in this case, we're wanting to question them about the bullying incident. So we have to, say that that's what we're going to do at the end. Okay? It has to fit in with what we are doing when it tells you why you are doing the sampling method. So for an unrestricted random sample, very similar. We're still going to put the pupils into alphabetical order. By surname. We're still going to number them from 1 to 1,200. We're going to use a random number generator to generate a random number between 1 and 1,200. We're going to repeat, and as I said in the other video, you don't have to say that you're going to include repeats, but you can do, until we have a sample of size 100, and then we're going to ask the selected pupils about the bullying incident. Now for a systematic sample, remember that starts off the same. We're still going to put the pupils into alphabetical order by surname. We're still going to number them from 1 to 1,200. But this time, remember that you have to do your side calculation. You need to do the population, which is 1,200, divided by the sample size, which is 100, which gives us 12. So that means that we're going to use a random number generator to generate a random number between 1 and 1,200. Oh, sorry, not 1 and 1,200. between 1 and 12 because that is what we got when we did our division. And then choose every 12th pupil after that until we have a sample of 100, and then we're going to ask the pupils about the bullying incident. For a proportional stratified sample, and you have to check what you're doing it by because of how the group split up. So this time we're doing it by year and gender. So we're wanting to take into account both the year and the gender of the pupils. So if we have a quick look at the data again, we're wanting to do a sample of size 100, but we have to say how many of each of these groups we are going to choose, okay? So the main part here is getting our numbers correct. So if you have a quick look back at the formula on the previous page, so back 2 pages, we're doing the number for the strata is going to be the number of people in the group divided by the population times the sample size. So if we have a look at our first group, the number in our group is 123, so we're going to do 123 divided by 1,200 times our sample size. For the second group, we're going to do 127 divided by 1,200 times our sample size. So we're going to do that for each of the groups. So for each one, we're doing the number of people in the group divided by the number of people in the population times our sample size, which is why I needed to select a sample size before I did this. So then we have 98 divided by 1,200 times 100, 102 divided by 1,200 times 100, and then 147 divided by 1,200 times 100, and 127 divided by 1,200 times 100. Now it's important that we know what each of these groups is. So across the top it was boys, down the side it was girls, and then we have years 7, 8, 9, 10 and 11. So for the first one we have 123 divided by 1,200 times 100 gives us 10.25, which we can then round to 10 because we can't take a quarter of a person. So we'll have 10 from year 7 boys. Then 127 divided by 1,200 times 100, which gives us 10.58, so we'll round that to 11. So we've got 11 girls from year 7. Then we have 146 divided by 1,200 times 100, which gives us 12.16 recurring. So we'll have 12 year 8 boys. Then 94 divided by 1,200 times 100, which gives us 7.8. That's 8 girls from year 8. Then 134 divided by 1,200 times 100, which gives us 11. So 11 year 9 boys. 102 divided by 1,200 times 100, which gives us 9 year 9 girls. And it also gives us 9 year 10 girls because we had the same amount in that group. 98 divided by 1,200 times 100 gives us 8.16 recurring, which means that we would have 8 year 10 boys. Then 147 divided by 1,200 times 100 gives us 12 year 11 boys. And finally, for the year 11 girls, well, we've got the same proportion, 127 year 7 girls, 127 year 11 girls. So that means that we'll have 11 of those as well. Okay, so we would use a simple random sample within the year and gender groups to choose a sample of the above sizes and ask them about the bullying incident. For a disproportional stratified sample, we would have to do, so this time we're only doing it between the year groups. So we're no longer splitting it by gender as well, we're just looking at the year groups. So because there are 5 year groups, we're going to have 1,200, sorry, not 1,200, 100, because that's what our sample size is, divided by the 5 year groups, which means that we want 20 from each year group. So we're going to take a simple random sample of size 20 from each year group and ask them about the bullying incident. For a judgmental sample, we are going to have the head teacher chooses 100 pupils. Now, if we have a look back at what the question's actually asking, the bullying incident is taking place on the school bus. So it would be a good idea for the head teacher to choose pupils that he knows take the school bus. So the head teacher is going to choose 100 pupils who take the school bus about the bullying incidents. And lastly, for the snowball sample, the head teacher can get a prefect or head pupil or something like that to feed back about any incidences of bullying that pupils tell them about. Now, the last part of this question asks us to explain which one of these is probably the most reliable and why. If you think about what it's actually talking about in the question, we're talking about a bullying incident that's happening on a bus. So I would probably say that the snowball sample is going to give them one of the better ideas of what's going on. The reason for that being is that pupils are more likely to tell a peer about bullying. So the snowball sample will be more reliable. In the same way, though, you could say that the judgmental sample is going to give you a better sample because you definitely know that those pupils take the bus. I mean, with a sample of size 100, you could end up using the top sampling methods and ending up with nobody who actually takes the bus. So either one of those would be fine to say it's the better choice. I'm now going to pause the video and give you a chance to do the Now You Try. Again, for this question, let's say that the sample size is 50 this time. So just to save some time, I've written down the answer and then I'll just talk through it. So for a simple random sample, we're going to list all the participants in order from date of birth, because that's the information that we have. We're going to number them from 1 to 2,400. We're going to use a random number generator to generate a number between 1 and 1,000 and 2,400, sorry. We're going to repeat this, ignoring any repeats that happen because it's a simple random sample, until we have a sample of size 50, and then we're going to include the selected people surveys in Sarah's analysis. For the unrestricted random sample, we would still list out all participants in order by date of birth. We would number them 1 to 2,400. We will use a random number generator to generate a random number between 1 and 2,400. We would repeat this, remember including repeats, until we have a sample of size 50. and then we would include the selected Pupils surveys. For the systematic sample, we would list all the participants in order by date of birth. We would number them 1 to 2,400. Then as our side working out bit, we'd do 2,400 divided by 50 to give us 48. So that means that we would use a random number generator to generate a number between 1 and 48 as our starting point. Then choose every 48th person after that. Sorry about that, and we would repeat until we have a sample of size 50, and we would include the selected participants' surveys. So for a proportional stratified sample of age and gender, we would have 3 males between 0 and 18, 3 females between 0 and 18, 7 males between 18 and 30, 9 females between 18 and 30, 13 males between 30 and 50, 10 females between 30 and 50, 3 males over 50 and 3 females over 50. And we would select a random sample from the age and gender groups of the specified size in that table, and we would include their surveys. For the disproportional stratified sample, we do our sample size, which is 50, divided by how many groups we have. Now this time it is still age and gender, so in total we do still have 8 groups. So it would have 6.25, however we can't choose a quarter of a person, so we're going to round that to 6. So we'd use a random sample to choose 6 people from each group of age and gender, and we'd include their surveys. For the judgmental sample, we can have Sarah choosing 50 surveys of people who went to the mall to see what they enjoyed. The reason why we chose about the mall is that Sarah is wanting to open a new mall, so that is in line with what she's wanting to do. So she can remember that the survey was only on people of what they like to do at the weekend. So Sarah could choose people that decided to go to the mall to see what they like and what they don't like. So for a snowball sample, Sarah could get shoppers to get other shoppers. She could get a shopper to get other shoppers to tell them what they like at the mall and feed it back. Another choice here would be to say create something like a questionnaire from from Facebook. And get them to post it on their wall, and then just as a lot of Facebook questionnaires do, once their friends answer the survey, then it can go out to their friends on their wall, and then they can do it, and she can get all the data fed back to her. So that is a good way that she could get a snowball sample about what a lot of people like at the mall, but it's not going to have any geographical restrictions on it that way. So for explaining which one of these is probably the most reliable and why, well, she could get a judgmental sample as they would have said that they like to go to the mall, so she'd get a lot of information from the surveys that they'd filled in. But she could also have said a proportional stratified sample, because then she would have a good idea of the genders and age ranges, and she could see what they like to do and try and incorporate that into what she wants to include in her mall. So I'd say anything like that, as long as you've got the sampling method and then a reason why you think it's going to give her the best information for what she's wanting to do, is a good answer to give. Thank you very much for listening.